Which way to look at gravity is more profound? Is Einstein's way, in which space-time fabric is a four-dimensional thing, or is it the exchange particle concept of gravitons? Which one is correct? Correct. Well, we know that general relativity, which looks upon space-time as a four-dimensional fabric, it is a stage upon which or within which the universe uh, plays out. So that definitely it is the best theory of gravitation that we have as of today. It is a very accurate theory. It all of its predictions thus far have been proven to be correct, and it is being tested all the time, and it is the most accurate theory that we have thus far. So Einstein's view, the four-dimensional space-time fabric, is definitely correct, but it is not completely correct, because we know that there are uh, certain scales at which it breaks down. For example, we are unable to quantize curved space-time, four-dimensional space-time. We are unable to do it. Quantum field theory is not compatible with general relativity, and we have these singularities that this theory throws up in the form of what happens within the hypothetical black holes. Space and time, the curvature becomes infinite, the mass energy density also becomes infinite. This is an indication that the theory breaks down at the quantum level, at the ultra microscopic level. So there's definitely a better theory out there somewhere. We still haven't figured it out. And one of the ways we are looking to do this is to quantize gravity, to have a quantum theory of gravity in which the hypothetical graviton will be the mediator of this force. It will be the exchange particle. Let me share this image. So this is the standard model of physics. This is the best theory of particle physics that we have, the best theory that describes the 5% of the universe that we can actually see. So you have these three generations of matter: the quarks, the leptons, and the gauge bosons. You have six quarks. You have the leptons, electron, muon, tau, lepton, and the corresponding neutrinos. Then you have the gluon, which is the exchange particle for the strong nuclear force. You have the photon, which does it for electromagnetism. And you have the W and Z bosons, that are the gauge bosons for the weak nuclear force. And then you have the Higgs boson, that imparts mass to various particles and which is responsible for the mass of the universe. Now, if the graviton concept is correct, then you would have one more 18th particle here, which would be the graviton, which would be the gauge boson for the quantum theory of gravitation, for quantum gravity. Well, thus far we have seen no evidence that this actually is correct. The graviton is a hypothetical spin zero particle boson. So this thus far has not been proven. It is far from being proven. So the best theory that we have as of today is Einstein's general relativity, four-dimensional space-time. But there could be a better theory out there, and that's what we are seeking. So maybe gravitons do exist, but we are very far from seeing any experimental evidence of gravitons, and very far from formulating a proper theory, a coherent, consistent theory of quantum gravity.